Alright, so we are going to look at quadratic functions, okay, and we are going to basically be looking at the same vocab that we learned before, so domain and range, okay, we're going to be looking at those. We're also going to learn some new vocab today. Okay, the first thing that we're going to do is we are going to go in our table and graph our linear parent function. Okay, linear functions we've already done. Okay, if you don't remember, pay attention. So, here it tells us f of x is the same thing as y. Y is equal to x. So, here, if x is negative 3, y is equal to that, so y is negative 3. So, if x is negative 2, what is y going to be? Y is going to be negative 2. Same thing if it's negative 1, and so forth. So we can fill in the rest of our table and knowing they're the exact same. So once we have that, we're going to go and we're going to plot our points. So negative 3, negative 2, negative 2, negative 1, negative 1, 0, 0, 1, 1, 2, 2, 3, 3. Okay? And we're going to draw our line. That is a linear function. A linear function, remember, is a straight line. So now we're going to look at a quadratic function. This is what we're going to get into a quadratic. So here, so g of x, same thing as y, is equal to x squared. So when we put this in our calculator, if we would have put in our calculator, we would put a parentheses around the negative 3, and we would put squared. Well, when we do that, we get that negative 3 squared is a positive 9. Negative and a negative make a positive. That's why it's positive 9. So then negative 2 would be 4, negative 1, 1, 0, 0, 1 squared, 1, 2 squared, 4, 3 squared, 9. Okay, again, if you need to bring your calculator, you could. I'm just going to kind of give them to you right now. So then we would go and plot. So on the x-axis, which is here, okay, we would go, and we would go 1, 2, 3, negative 3, and we would go up to 9. We'd go to negative 2, we'd go up to 4. Negative 1, we'd go up to 1. 0, we would go to 0. 1, we would go to 1. 2, we would go to 4. 3, we would go to 9. And we can see the u that it makes. Okay, so we're going to get a parabola for a quadratic function. It's going to look like a u, either upside down u or just a normal u. So, the questions that it asks are, what do the two graphs have in common? Okay, so when we think about this, we're seeing anything that you can think they have in common. Okay, so it can be anything, it can be different from what I write. Okay, but what they have in common is, okay, they're both continuous. We should know what the word continuous means. Continuous is whenever there is a line connecting all the points, which we're going to have. Okay, we have there. They also have the same x values. Okay, the difference is a linear one is a straight line. A quadratic is a curved line. Okay, also, their y values are different. Okay, so then if you look at number 2, it's asking us about the domain. Okay, remember what the domain is. Think about it. Okay, domain are all of your x values. So if we're looking here, because of the arrow right here and right here, it means it's going on forever. So all the way to the left, all the way to the right, which is going to mean it's going from negative infinity to infinity. Do they have the same arrows over here? Yes. Okay, they're both going up, but that means they're still going out. So they will continue going out, and out as they go up. So again, my domain is infinity, negative infinity to infinity, these two radius. So, it's asking what is the domain. Do they have the same one? Yes. Negative infinity. Now we put our less than x, less than infinity. You can also write all real numbers. For our range, okay, is our range the same? If we look, oops, we have an arrow going up and an arrow going down for our linear. But if you look over here, we only have arrows going up, so we can continue going up. But what's the lowest that it can go? The lowest it can go is 0. So are they the same? No, they're not. So for our linear one, if they can go all the way to the bottom, that's negative infinity. If they go all the way to the top, what is that? Positive infinity. For quadratics, for this one, what was the lowest it could go? The lowest it could go was 0. What does that include on the line? Yeah, it's 1 point, so it's going to be included. And what was the highest it could go? The highest it could go because of the arrows was infinity. Okay, so that's how we're going to be able to tell the difference between the two is going to be their range. Domain the same, range is different. Okay, we're going to look a little bit more into this. If we don't really truly remember this, we're going to hopefully remember by the end of this. Okay, so if we look at number 1. So we're going to fill in our table first. Now, again, in your calculator, you would be able to do this. In your calculator, if this is what you're looking for, you would have parentheses, -4 squared minus 1. Parentheses, -3 squared minus 1, and so forth, okay? But we know that -4 squared, and remember it's on the board too, 4 squared is 16. 16 minus 1 is 15. -3 squared, we know 3 squared is 9, minus 1 is going to give me 8. -2 squared is going to give 4. I subtract 1, that gives me 3. -1 squared is 1, minus 1 is 0. 0 squared is 0, minus 1 is -1. 1 squared is 1, minus 1 is 0. 2 squared is 4, 4 minus 1 is 3. Are we seeing a pattern now? Where after this one we have 0, 0, we have 3, 3. So what do you think is going to come next? 8 and 15 and 15. You'll always be able to see a pattern when we're looking at the quadratic. So we're going to plot our points. So on the x-axis here, we're going to go to -4. We're going to go up to 15, the dot. We're going to go to -3. We're going to go all the way up to 8, put a dot. We're going to go to -2. We're going to go up to 3, put a dot. We're going to go to -1. We're going to go to 0, put a dot. And then we're going to go to 0, -1, put a dot. Then 1, 0, put a dot. 2, 3, put a dot. 3, 8, put a dot. And 4, 15, put a dot. We're going to draw, I'm not going to draw arrows right now. We're going to connect all of our dots. Okay. So on A it says, put a box around the y-intercept. Well, we know the y-intercept is where it touches the y-axis. So if we look on here, where is it touching the y-axis? The y-axis is right here. So it touches it down here at -1. Okay, and we're going to put a circle around the x-intercept. So we know y-axis is where it touches the y-axis. The x-intercept is where it touches which axis? The x-axis. So here's the x-axis. It's going to touch it twice. It's going to touch it here at -1, and it's going to touch it at 1. It's not a case. Okay, moving on. So now, if we look, arrows. Okay. So it says, if we look at our graph to describe the domain, so my x values are going to be between -4 and 4. If we look, is that right? The farthest left we go is -4. The farthest right we go is 4. Okay. Now I'm saying to put in your calculator. We're not going to put it in our calculator today, but we're going to look. If there, in a calculator, whenever you do it, basically all it's doing is it's going to continue on. So, if there were arrows, and so with the arrows, what that means is it's going to continue out and it's going to continue on forever. So, what would your domain be? Would you go, would it ever stop? It wouldn't ever stop, because it can't. There's nothing making it stop from going out. So, for my domain, I have my x, I have my 2 lesson signs. The farthest left it can go is going to be negative infinity. The farthest right it can go is infinity. And what else is that called? All round numbers. Okay. Then it's asking it about the range. So if we're looking at my range, can it go all directions? Is it going up forever? Is it going down forever? It's not going down forever. Why is it not going down? Where is the farthest or the lowest it can go? The lowest it can go is right here, which is what? -1. So for my range, and my y, my 2 less than signs, now the lowest it can go is what? -1. Is -1 included? Is it on that line? Sure is. Okay, and where's the highest it can go? Well, those arrows continue to still go on forever, so what is that? That's infinity. Okay, now it's telling us to add a line x equals 0. That has to cross the x-axis, which means it's going to be a vertical line. Okay, so if we look where x is 0, we're going to go and we're going to draw a line down the middle. That's symmetry. If we look, we take our axis and we go 1 to the left. Does that touch my x-axis? Yes. If we go 1 to the right, does that touch my x-axis? My x-intercept? Yes, it does. Okay, and that was 1 and 1. Are those the same? Yes. That means that this line is symmetrical. Symmetrical means it's the same on both sides. Okay, so we know we're right there. Now, if we look, what point does it change direction? Basically, all this is saying is, where does it have to stop at? So if we look, it's changing directions or stopping where we said right here was. Well, what is that point? We know that the y is -1. What is the x? The x is 0. So my point is 0, -1. It's asking a maximum or minimum. So a maximum is the highest point on the graph. The minimum is at the lowest point on the graph. If we look at our graph, would that be the highest point or that would be the lowest point? So lowest point, so that is our minimum. Okay, so what I want us to know is this is our same thing as our vertex, where it's changing. When we have our vertex, this x-axis, this x value is going to be where we're going to draw our line of symmetry. And this y value is going to be in our range. Okay, so when we move to the next one, I want us to remember this. So if we look here, it's telling us put a box around the y-intercept. Okay, we know y-intercept is where it touches the y-axis. It's telling put a circle around the x-intercepts, so where it's touching the x-axis. Okay, now, I want us, before we move to this question right here, what is the point at where it is changing direction? Right here, right? It changes direction, that's the highest it can go. It has to change direction to go back down. What point is this right here? Well, my x value, is 2. my y value is 9. So, we just looked here. For a vertex, or where it changes direction, the x is my line of symmetry, the y is going to be my range. So, what would be my line of symmetry? My line of symmetry, my x is equal to 2. Well, here's my answer. Okay, now, let's check ourselves. We're going to draw that line of symmetry. So we're going to go right where that vertex is, that x is equal to 2. And we're going to count how many to the left gets my x-intercept. 1, 2, 3. How many to the right gets my x-intercept? 1, 2, 3. Okay, so is that equal? Yeah, so yes, I know I'm right. Okay, then we look. What is the vertex? So the vertex is where it's changing direction. Did we already find that? We did, we found it right here. So my vertex is 2, 9. Now it's asking maximum or minimum. Okay, now the maximum means it's the highest it can go is cut off. Okay, if you go to the store and they say, yeah, here's $150 to buy shoes, can you spend more than $150? No, you can't. So the minimum $0, right? Because you get whatever. You don't have a minimum. Okay, you can spend 120, you can spend 100. You can go to wherever and buy $10 shoes. Okay, it does not matter, but your maximum is $150. So if we look here, if it's cutting us off at the top, what's that going to be? That's going to be my maximum. Okay, then it's asking us the domain and the range. So if I'm looking here, are there arrows going right here? There's not arrows, right? So is it going to infinity? No, it's going to right there. That's as far as it can go. So the farthest left it can go is 2.5. Whoops. Is 2.5. Is that included? Yeah, it's included, because that's where the line is. Where is the farthest right it can go? The farthest right it can go is right here, which is about 6.5. And that's included as well because that's the line that we're looking at. Okay, then we're looking at a range. So the lowest it can go, can it go any lower than -10 right here? That's where it stops. Does it go past that? Are there arrows? No. So this is going to be the lowest that you can go. So -10 is the lowest that you can go. It's included because it's on that line. Okay, then you're looking. Where's the highest? Well, the highest is where we change direction. The y value there is 9. It's also included because it is touching that line. Okay. Now, for 3, 4, and 5, you're going to do. Okay, you're going to turn it into them before you leave. Okay. Looking at the same thing. Remember your vertex. It's going to be a point. You're choosing maximum memory. Your axis of symmetry is going to be what x equals this value. X-intercept y-intercept we know. Okay. If it's coming off the graph like this, that means that my range is going to, or my domain, no matter what, is basically saying there's arrows here. Okay, you're going to finish that. If you have questions, you can come see me tomorrow for tutorials.
Can I see it?